We are starting now with the new topic of combinatorics. In combinatorics problems, the question is always in how many ways can something be done, or in how many ways can something occur. To understand how this is meant, read example 1, which is about the famous traveling salesman problem in mathematics. A salesman wants to visit a number of cities, and he wants to visit them in an order such that his traveling time is the shortest possible. In this specific example, he starts and ends in Zurich and visits Basel, Bern, Geneva and Lucerne. Question is, how many different journeys are possible? The example here shows one possible journey. So he starts in Basel, then goes to Bern, Geneva and then Lucerne. However, there are many other possibilities. For example, he could instead go first to Bern, then to Basel, then to Lucerne, and then to Geneva, before going back to Zurich. Question: how many different journeys are possible? Well, as a first destination, he can choose between all the four cities, Basel, Bern, Geneva, and Lucerne, so he has 4 choices. Since he has chosen already one of the 4, for the next city, he can choose only amongst 3 of them, and then amongst 2, and then amongst 1. And since he can now combine, once he's chosen the first city, let's say Basel, he can choose amongst the other 3 cities. So he has, for having chosen Basel first, he has 3 possibilities for the second city. The same is if he chose for the first city Bern, again he has 3 possibilities, which means we have to combine each of them with each other. So we have just to multiply them, getting in the end 24. By the way, we write this 4 times 3 times 2 times 1 as 4 factorial. 4 with an exclamation mark. We'll look at that very soon. Let us now assume that he wants to visit 27 locations, not only 4. So the number of possible journeys is now 27 for the first location, times 26 for the second one, and so on, times 3 times 2 times 1, which yields, well, make a guess. Stop the film now and continue once you have made the guess. Okay, here comes the result. It's 1.1 times 10 to the power of 28. Just to realize what enormously large number this is, imagine that you were able to look at 10 journeys every nanosecond. So if you had started from the beginning of the universe, so from the Big Bang, by today you would have managed only to look at half of all these possible journeys. We write this again just as 27 factorial. In example 2, we look at 8 friends playing Schieber every evening that they meet. And in Schieber, you always team up with one player and you play against another team. Since there are 8 players and in every game there are 4 players, they can play 2 games at the same time. And now the question is, how many evenings do they need to meet so that they play all possible games against one another? This means, for example, John wants to play with Beat against Anna and Carla. He plays with Beat against Anna and Daniela, and he also plays with Anna against Beat and Carla, and with Anna against Beat and Daniela, and so on. So he teams up with everybody and plays them against any other possible team of 2 exactly once. And that's the same for all of them. How many evenings are needed for that? Well, you can have a guess, and I tell you now the result. It's 105.